Hello, this is Math 1115, alternative delivery for 23rd March 2020. Please use your tools to play, rewind, and some opening remarks. Pause. There will be a quiz over chapters 3 and 4. We did a little bit of 3 and all of 4. Will be posted in Blackboard. Students should complete this quiz prior to our spring break, and they can do this with open notes and open books. John can help you with similar problems, but not with the quiz problems themselves. This quiz will be covered along with the grading rubric in the next posted lecture. And as discussed in previous correspondence, it will be self-graded and self-reported. Spring break is looming, so get it done. Chapter 5 will begin after spring break, and as before, teaching and learning continue unabated. We're now going to do a series of problems because this chapter is called applications, and so applications tend to be word problems. Here's the first one. In 2000, about 70 metric tons of soil were removed from under the Leaning Tower of Pisa, and the angle of the tower made with the ground was increased by 0.5 degrees, that is half a degree. And so they're doing this to increase the angle to stop it from leaning quite so much. Before that, a point near the top of the tower was 50.5 meters from a point at the base measured along the tower. And this top point was directly above a point on the ground 4.25 meters from the same base point. How much did the point on the ground move toward the base point? Have to think about this for a while. Press pause, do some work, and come back and we'll see how you did. I'm back, and let's see how you did. So we wanted to find how much this base point moved, and the base point previously was 4.25, so we split the bottom into 4.25 minus x and x. And so now what we're going to do is we have a couple of triangles. The first triangle that we're going to look at is the big triangle. So this whole side here is 4.5, and the hypotenuse of this triangle is 50.5. That means that the cosine of the angle theta shown there is 4.25 over 50.5, and we can use our calculator's inverse trig functions to find out that theta is 85.2 degrees. Now, if we look at the big triangle, what we did is we increased the angle by half a degree. So that means in the new triangle, what we have is the angle is going to be what theta was before, 85.2, but then we're adding half a degree to it. So the cosine of that new angle is going to be 4.25 minus x over 50.5. And so we will solve for x. So we multiply both sides by 50.5, and then we subtract the 4.25 and divide by minus 1, and we find that x is 0.44 meters. Let's look at another problem. A bullet was fired such that it just grazed the top of a table. It entered a wall which was 12.6 feet from the graze point in the table at a point 4.63 feet above the tabletop. At what angle was the bullet fired with the horizontal? And there's a picture. Please pause, do the problem, and come back for the solution. I'm back to discuss your solution. Not too bad, really. The tangent of A has to be the opposite over the adjacent. And so A is going to be the inverse tangent of that ratio, and your book should tell you that that is 20.2 degrees. Here's problem 9. In a series RL, that means a resistance inductance circuit, the impedance Z can be represented as the hypotenuse of a right triangle that has legs resistance and exabar, which exabel, and xabel is called inductive reactance. The angle theta between R and Z is called the phase angle. And so this is asking you to find the impedance and the phase angle. So you have to find what is Z and what is the phase angle. Now I am not doing this problem with you right now, but I did include it because I wanted you to know that you do have to know both the Pythagorean theorem and how to do trigonometry when you're studying your electronics technology courses. Let's look at a problem we actually are going to do, number 10. And this is a surveying problem. In order to determine the length of a lake, shown in the picture, a surveyor takes poles into A, B, and C and measures the angle with its transit, and you want to determine the length of the lake from point D to point E. Okay, so press the pause button, work through the problem, and come back and we'll see how you did. I'm back. Let's see how you did. Alright, so in the picture you can see that in the right triangle the cosine of 37.28 down here is going to be the adjacent 875 divided by the length from point A to point B. Here's point A way over here, and point B is way over here. Okay, so what we can do is we can solve for the length of AB, and we do that. We get AB is almost 1,100 feet, but now we had two pieces on the ends that we have to subtract off, so the length from D to E is 1,036.78 feet. Let's do another problem. This has local color. This is the Willis Tower in Chicago. It can be seen from a point on the ground known to be 5,200 feet from the base of the tower. The angle of elevation from the observer to the top of the tower is 16 degrees. By the way, because of a problem we're doing later, realize that the top of the tower is not considered to be the top of the antenna at the top. How high is the Willis Tower in Chicago? Press pause, do the problem, and we'll come back and see how you did. Let's see how you did. Not too bad. The tangent of 16 degrees has to be h, which is the height, over 5,200. And you solve this by multiplying both sides by 5,200 and using your calculator. You get h is 1,490 feet. Let's do another problem. Going from Chicago to London. Part of the Tower Bridge in London is a drawbridge. This part of the bridge is 76 meters long. You can see that in the figure. When each half is raised, the distance between them is 8 meters. What angle does each half make with the horizontal? This is an important engineering kind of problem. And so the thing to do is to pause, work on the problem, find your solution, and then press play, and we'll see how you did. I'll be back in a bit. Press pause now. Okay, I'm back in a bit, so let's see how you did. Well, here's the picture, and what you can see is that if you're talking about the length of each of those, if I take 2A, if I take 2A and I add 8 to it, I will get the 76. That means I can solve for A, and A is going to be 76 minus 8 over 2, or 34. So that is what A is going to be. Now, whenever the bridge is flat, the ends must meet in the middle, so the hypotenuse of each right triangle is half the span. And so A is half of that, which is going to be, or H is going to be 38. And so when I combine these two facts together and I say, looking at the picture, I can see that the cosine of capital A is A over H. That means that A is the inverse cosine of 34 over 38, and we get 26.5 degrees. Here we have another problem. Again, another surveying problem. A surveyor on the New York City side of the Hudson River wishes to find the height of a cliff called the Palisades. on the New Jersey side, excuse me, and there's a picture and the measurements that are made. Now it is a little bit tricky because you have to realize that this is a 90-degree angle, and so that's what we have. And in fact, they tell you in the figure the triangle containing the height h is vertical and perpendicular to the river. So press pause and work through the problem and hit play, and we'll see how you did. Let's see how you did. Well, and so what we're going to do is we're going to begin by saying if x is the perpendicular distance to the both's path, we say that x over 482.6 is equal to the tangent. So what we're doing is we're looking at this triangle right here, this one. That means that x is, I multiply both sides by 482.6 times that tangent, and I get x. So that tells me what x is. And so now to find the cliff height, h, we're looking at the other triangle. And so we have that the tangent of this angle is h over, and this was the distance x that we found earlier. And so h is 221.1 feet. You see we had to do two separate triangles in order to do this, this problem. Next problem. Two ladders, each 6.5 meters long, are leaning against opposite walls of a level alley with their feet touching. If they make angles of 38 and 68 degrees respectively with the alley floor, how wide is the alley? The biggest thing on this is figuring out, I think, the picture that you need to draw. So pause, draw your picture, solve the problem, and we'll come back and see how you did. Let's see how you did. Well, here's the picture that you need to draw. This is where the feet of the are touching. So you have x plus y is equal to, and it's going to be x is going to be 6.5 times the cosine of the 38 degrees, and the y is going to be 6.5 meters times the cosine of 68 degrees. You pound that into your calculator and round it off, and you conclude that the alley is 7.56 meters wide. Let's do another problem. A tract of land is in the shape of a trapezoid. Here's the picture. Find the lengths of the non-parallel sides. So we want to find the length of this side and this side. Press the pause button, work the problem, and I'll be back in a bit. I'm back in a bit. Let's see how you did. Well, what we're doing is we're dropping the perpendicular from the top base to the bottom base, and that allows us to figure out some things. And so when we do that, we're going to relate the quantities w, x, y, and z in my figure. Okay, so the cosine of the 69.2 degrees angle is going to be w over x. And that means w is equal to x times the cosine of 69.2. The cosine of the 41.7 angle is going to be the adjacent over the hypotenuse, and that is going to be z over y, and so z is equal to y times cosine of 41.7. So w plus z plus, and I'm adding these two, you see I'm adding w and z, so when I add those, and I add the 68.7 in the middle, I get 148. And so that means that we're going to be able to solve for w plus z, and let's see, so w plus z is that, so and W was x cosine this and y cosine that, and so we get this expression. So we know 0.3551x plus 0.7466y is 79.3. But now we need to introduce h. And so we know that W over x, and we can conclude also that h is equal to x sine 69.2 degrees. That's from the figure. We also know that h is equal to y in the figure times sine of 41.7 degrees. So those two things are equal to each other, so I can set the two things equal, and I can solve for y in terms of x. So now I can take this and I can substitute back into my original equation where I had x plus y adding up to 79.3, and I can solve this for x, and once I have x, then I can solve for y using one of the expressions that I have for that, and I can conclude that in fact I'm going to just use this expression right here between x and y, and so y has to be 79.4. Neat, huh? Let's do another problem. Now this has an antenna on top of the World Trade Center. Before it was destroyed, there was an antenna, and we're talking about the height to the antenna now. From a point on the river 7,800 feet from the center, the angles of elevation at the top and bottom of the antenna were 12.1 degrees and 9.9 degrees respectively. How tall was the antenna? We're to disregard the small part of the antenna near the base that could not be seen. And we have a little bit of a picture there. I have asked problems like this on tests before, so please work to understand this. First thing, of course, is to draw the picture. Hit pause, draw the picture, and work through the problem, and come back and see how you did. Let's see how you did. So here is the picture that we get with the information. So we see that the tangent of 9.9 is going to be what is shown in the figure as x over 7,800. Similarly, the tangent of the bigger angle, 12.1, is y over 7,800. The antenna height, of course, is h, but h is going to be the difference between y and x. So h is going to be the difference between those two, and we get that h is 310 feet. So now we're wrapping this up. Remember that there is going to be a quiz for you to do next time before the midterm, but now this is the benediction. Time, now more than ever, is precious. Each day must count. Do the math. It will make you strong. And please take care of yourself. Bye for